The FastFin system is an elegant, no-moving parts solution to an inherent weakness seen in many early enclosed tailboom helicopter designs. Limited tail rotor authority, which significantly reduces the potential lifting capacity of a helicopter and may compromise safety margins in challenging operational conditions. The FastFin system incorporates two parallel stall strips along the left side of the tailboom and reshaped vertical fin. These modifications combine to optimize airflow around the tailboom. With FastFin installed, your bell medium can realize certified useful load increases up to 91%. And even more compelling, BLR's FastFin will all but eliminate the sudden and seemingly unpredictable loss of tail rotor effectiveness, known as LTE. How is this possible? The answer is aerodynamics. Studies by NASA and BLR reveal that rotor wash over the tailboom enclosure causes the tailboom to act much like a wing, creating adverse low pressure along the left side of the tailboom. This adverse low pressure works against the efforts of the tail rotor, causing the tail rotor to require higher thrust. NASA studies also show that the low pressure phenomenon is not a constant force. Kármán Street vortex shedding causes the low pressure to fluctuate continually, creating instability and requiring the pilot to constantly make corrections for yaw. This is, in fact, the phenomenon that makes helicopters so difficult to fly. Fluctuating air pressure shakes the tailboom left and right, and constant pilot corrections are necessary to achieve a steady and safe state of hover. By reducing required tail rotor pedal reversals up to 35%, BLR's FastFin system not only reduces the stress on the aircraft and pilot, it also increases the aircraft's safety performance in hover. In additional research, it was demonstrated that by installing stall strips, or strakes, on the left side of the tailboom, the low-pressure area acting on the tailboom is reduced, which in turn reduces the horsepower required by the tail rotor. Valuable energy can now be redirected to the main rotor, allowing for significant increases in useful load. The tail rotor produces anti-torque force by thrusting air sideways. Some of that air is driven into the vertical stabilizer, reducing overall efficiency. By relocating material away from the affected areas, FastFin has reduced energy loss while retaining weathercock stability in forward flight. By introducing a newly shaped trailing edge, which closely resembles the shape of the leading edge, dramatic increases in wind azimuth tolerance can be achieved. When both modifications are combined, the result is an incredible increase in tail rotor effectiveness during hover and in low-speed operations. Simply put, the easy-to-install FastFin system modernizes and improves the aircraft by optimizing the airflow through the tail rotor and over the tailboom, increasing tail rotor efficiency, which preserves precious engine horsepower for the main rotor and increases available yaw control to optimize the lifting capacity of the helicopter.